All right, so welcome back to Mr. G's lab. So today we are going to be figuring out molar masses, which you've done before, but we're going to also be looking at percents, and we can take percents and we can convert them to grams. So we need to figure out the atomic mass, the molar mass of this compound, Ca3P2. So that's your very first step. So you're going to basically you're going to list your elements, Ca and P, and atomic mass, and then times pieces. All right, and you're going to make your little grid, hopefully better than I am. And you look to see what your atomic masses are. Calcium is 40. That's supposed to be a 4 right there. And phosphorus is 31. And we have in our formula Ca3, so we have 3 pieces of calcium. And phosphorus, we have 2 pieces of phosphorus, and multiply them. So 40 times 3 is 120. And 31 times 2 is 62. Add that all together is 182. 182 grams per mole. So now the part that you do is you take calcium and you always put the number small. So when you're working with percents, most of the time, not every time, but most of the time, put the small number on top. So 120 divided by 182 equals uh, equals 0.659 times, and we multiply it by 100 to get our actual percents. So that would give us 60, because 100, we want to move it over 2 spaces. 65.9% is calcium. And then we can look at our phosphorus, and we can do 62 divided by 182, which equals 0.34 and 1. So times 100, because we want percent, we're not just looking at the decimal. So we move it over 2 places, 1, 2, because that's how many places we're moving it over for our 100%. So 3, so that'd be equals 34.1%. And if we add it all together, that gives us 100. So Ca3 has 69% calcium and 34.1% phosphorus. And I've put the answer down on the bottom, and our answer corresponds. The total atomic mass is 182.3. Its percentage is 66%, which is pretty close. I said 65.9, and 34% for phosphorus. And that is how you figure out percents. And I want to remind everybody, since I gave you the answers, you have to show me your work. If you don't show me your work, I'm not going to give you full points. I may give you a few points, but not enough to make it worth your while. So, what is the percent composition of oxygen in each? We'll go with number 9 of each of the following materials. So, again, let's look at F, copper sulfate pentahydrate. So, we basically have to include the water that's included. So we basically have to figure out what the total atomic mass is for copper sulfate pentahydrate. So we have to make our little grid. Cu and then S and O and H. Okay. So atomic mass of copper is 64. So copper is going to be 64 is its atomic mass and times the number of pieces. So sulfur is going to have an atomic mass of 32, and oxygen is 16, and hydrogen is 1. The number of pieces of copper, that one's easy, that's 1. Sulfur, again, 1. And O4 is 4, but we also have 5, so there's 9. 4 here, and 5 here. Remember, there's hidden ones, 5 times 1. And then hydrogen, it'd be 5 times 2. Is that right? Copper is... Yeah. Yeah, sorry, I had to think for a second. So hydrogen is 10. So, equals, and equals. So now that gives us 64 for copper, 32 for sulfur. 16 times 9 is 144. And hydrogen is 10. So the question is, what is the percent composition of oxygen in each of the following materials? So you only have to figure out the percent of oxygen in the materials. So you have to find your atomic mass. So if we add all that up together, we get 250. Okay, 250. So then we look at, again, it's fairly easy. We take what we're given, we put the small number on the top, we put the small number on the numerator, the top number. So we have 144 divided by 250, which equals 0.576, and we multiply that by 100. And that gives us 57.6. Okay, so that's our percentage. And if we look at F, we have 9F, and there's our answer. And that, ladies and gentlemen, is it. If you have any questions, feel free to um, feel free to email me or text me or call me. For those of you not in my class, leave a message below and I will get back to you as soon as I can. That's it. Peace out.